today I'm going to look at the chapter review, which starts on page 432. Make sure you're looking at the chapter review and not the self-test. So the first question, I already went and set up the table. It's looking for the difference between two dice when we throw two dice. So number one wants to know what is the probability that that difference is less than 0. So first of all, we can quickly see there's a total of 36 outcomes. Less than 0 starts here and is below. Looks like it's 15 out of 36. We'll go ahead and reduce that and we get 5 out of 12. The next one wants to know that D is an integer. Well, if you remember, integers are whole numbers or their opposites, so that actually includes every single number on here. So question number 2 is 36 out of 36, which is equal to 1. Question number 3, again, I recreated a 2-dice sum chart for you below. They want to know what's the probability you get doubles. Doubles are sitting on that diagonal. So there's a 6 out of 36 chance, 1 out of 6. Question number 4 wants to know what's the probability the sum is prime. So a prime number is a number that has two factors, which is 1 and itself. So that would be 2, the 3s, the 5s, 7s, and 11. I total those up. Again, I get a 15 out of 36, which reduces to 5 out of 12. Alright, moving on to question number 5. It says 3 fair coins are tossed. So I'm going to go ahead and... So on my first toss, I have heads or tails. Heads or tails on my second toss, and on my third toss as well. Now again, you don't have to do the tree diagram, but it certainly helps you organize all the outcomes a little bit better. So notice you've got 3 dice. I have 2 outcomes on the first, 2 on the second, and 2 on the third, so I have a total of 8 outcomes. Question number 5 wants to know when am I going to get all heads? Well, that's this case right here. Head, head, and head. So that would be a 1 out of 5. Or excuse me, 1 out of 8. Question number 6 wants to know 2 heads. So that would be this case here. That's 1. That would be a second case, a third case, and that's it. So 3 out of 8. Question number 7 wants to know I get at least 1 tail. So I can total all those up, or I'm going to again refresh your memory on that complements. The opposite of 1 tail would be no tail. So I could do 1 minus the probability of no tails. And that situation is only the HHH, which is what we looked at on the top. So 1 minus 1/8, and we end up with 7. Question number 8. They give you a percent of population is 1.3% that has color blindness. They give you a graduating class of 1,200. They want to know how many would you expect to be blind. This is similar to some of those questions that we saw on the quizzes. So we are taking 0.013. We are multiplying it by the 1,200. And when I do that, I end up with an answer of about 16 students. See if we can squeeze on number 9. It says, what is the expected count for the outcome of 3 when I toss a die? Well, I have a normal 1 out of 6 probability for rolling a die out of a total of 230 outcomes. And when I multiply those together, I end up with about 38.3 repeat. Okay, question number 10 is similar. It says 4 have 0.047 times 532 students, and we would end up with approximately 25 students.
Question number 11. How many possible strings are there for the letters in the word tropical?
So if you wanted to visualize, there's 8 letters, 3, 4, 5, 6, 7, and 8. So I have 8 letters here, 7, 6, 5, etc. Or you might quickly recognize that's the same thing as 8 factorial. When I plug that in, I get 40,320.
Number 12, in the next case, all they want you to do is select
3 letters. So again, if you want, we could use the counting principle. There's 3 letters. I have 8 for the first, 7, and 6. That's also the same as taking 8 letters and choosing 3. And I misread it. It actually says you can't have the letter A. So that would be 7, 6, and 5, or 7P3. Plugging that in, I get 210. 13. How many 5-letter permutations can be made from the letters in the word cabinet? So again, I have 7P5. I'm just going to emphasize that formula. Remember, your formula would be n factorial over n minus r factorial. That's 7 factorial over 2 factorial. 7, 6, 5, 4, 3, 2. And eventually I get 2,520. 14. How many 3-letter permutations can be made from cabinet that start and end with a vowel? So again, we've got 3 letters. Now I have to start with a vowel. If you take a look, there's only 3 vowels, A, I, and E. So I've got 3 letters. I'm picking one here. Once that one is placed, when I go to end it, I only have 2 vowels to pick from. And again, I'm placing 1. And then I've got 5 letters to pick from for the middle for that location there. And I can plug that all in my calculator, and we end up with 30. Question 15, it wants to know how many outcomes are there if I toss a coin 8 times. Well, if you want to write out all spots, you can, or notice that's the same thing as 2 to the 8th. And again, if you need the visual, alright, moving on to question number 16. It says evaluate without using a calculator. I think 16 you can quickly do. I'm going to skip and take a look at 17. So 17 is 9 factorial, 5 factorial, 4 factorial, 3 factorial. Okay. Okay, so the first thing, I expanded the 9 factorial down to 5, so those can cancel out, and then I'm just canceling out common factors between the numerator and the denominator. I have 4 times 2, which is 8, so that can cancel with the 8 in the numerator. I have 3 times 3, which is 9, so that can cancel with the 9 in the numerator. I finally see 42 over 2, eventually simplifies to 21. I'm going to skip to number 19. They want me to write it as a product of integers. So I have 54 factorial over 50 factorial. So we're just going to expand it again down till we get to 50 factorial, which cancels in the denominator, and there's your final answer written as the product of integers. Let's take a look at one more of those. Number 20 involves an algebraic expression. So we want to expand the a plus 2 factorial because that's the larger one. So this would be a plus 2, and then if you can envision, this next one is a plus 2 minus 1, which simplifies to a plus 1. And again, I have a plus 1 in the denominator. denominator, those cancel out. My final answer is a plus 2. Question 21. And all of those you can just plug into your calculator. Let's go ahead and take a look at maybe 23 though. It says NP1. That means I have n factorial over n minus 1 factorial. Again, if I expand the larger, that becomes n times n minus 1 factorial, which eventually cancels out in the denominator, and we are left with n. 24 we actually didn't cover, so you can skip that one. Number 25, it says, if A and B are complementary events, then the probability of A union B is equal to what? Remember, when they're complementary, that means they're complete opposites. So in question 25, that means the probability of A or B means their overlap. Well, they have no overlap because they're complete opposite groups. 26. Explain why the probability of A and B cannot be mutually exclusive. Well, if you take a look at 26, if they're mutually exclusive, then the probability of A or B is supposed to equal the probability of A plus the probability of B. Well, when I go and add the probability of A, which is 0.6, and I add 0.7, I end up with a probability that is greater than 1, and we know that can't happen. So the only way to get it back to down to a probability that's equal to 1 is we have to turn around and subtract something that overlaps, which means these are not mutually exclusive. '27. They want us to find the probability of not A or B. So not A or B is the complement of having A or B. So I'm going to go and find the probability of A and B. Of A or B, and then I'm going to subtract it. So the probability of A or B, and it says they're mutually exclusive, so that would be just 0.25 plus 0.3. So when I add those together, I get 0.55. Finally, when I subtract from 1, I get 0.15. Okay, question number 28 wants to know, what's the probability of randomly choosing a positive number less than or equal to 100, and it has to be either a perfect square or a perfect cube? Well, first of all, I've got 100 numbers, so I'm looking for numbers that are perfect squares, so that would be 4, 9, 16, 25, 36, 49, 64, 81, and 100 perfect cubes. Well, 2 to the third would be 8, 3 to the third is 27, 4 to the third is 64, and 5 to the third is 125. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of 100, or 0.12. 29. Determine whether the events are independent or dependent. So I'm looking at the probability of A times the probability of B has to equal the probability of A and B. The probability of A I've been given is 0.4. The probability of B is 0.25, and the probability of A and B is 0.1. So I end up with 0.1 equals 0.1, so these are